on Gay-Lussac'S law. And Gay-Lussac'S law states that the pressure exerted by a gas that is of a given mass and the volume is kept constant varies directly with the absolute temperature of the gas. In other words, the pressure exerted by a gas is proportional to the temperature of the gas when the mass is fixed and the volume is constant. So what does Gay-Lussac'S law state? It states that from there to there. That's what Gay-Lussac'S law states. It states that the pressure exerted by a gas varies directly with the absolute temperature of the gas provided the volume is kept constant. So let us check what it implies. That will be pressure. Varies directly to its absolute temperature. So at a constant volume, where if we rewrite this one, we'll have K equivalent to pressure all over temperature. Now when comparing two gases, we'll have K1, we'll have this one as K1, we'll have this one as K1, P1, T1. When we have another gas with a constant volume K2, we will have P2 over T2. So when you are comparing this, to compare the two gases, we'll have P1 over T1 is equals to P2 over T2, where P stands for pressure and T stands for what? Temperature. And with that, we are going to look this example with this formula for Gay-Lussac'S law, where we have the pressure. Example 1 states that the pressure of a gas in a cylinder when it is heated to a temperature of 250 Kelvin is 1.5 atmosphere. What is the initial temperature of the gas if its initial pressure is 1 atmosphere? So we solve this. We'll highlight whatever we have. We have pressure 1, temperature 1. Pressure 1 we have been given as 1.5 atmospheres. And then temperature 1
will be 250 plus 270.
Wait, just wait a minute. Is this pressure 1? We have been told that the pressure of a gas in a cylinder when it is heated to a temperature of 250 Kelvin is 1.5 atmosphere. What is the initial temperature of the gas if its initial pressure is 1 atmosphere? So pressure 1, 1 atmosphere. We don't have its temperature. That's what we are going to look for. And then if we continue, we check for pressure 2, which is 1.5 atmospheres. and then
Yeah.
its temperature is what? 250 Kelvin.
Kelvin.
So the temperature must always be in what? Kelvin. So our temperature is in Kelvin. So you want to calculate the initial temperature for this gas. So we apply the formula P1 over T1 is equals to P2 all over T2, where if insert this, we will have 1 atmospheres all over T2 is equals to 1.5 atmospheres 1.5 atmospheres all over 250 Kelvin. So to get T2, we can cross multiply. If we cross multiply, this one multiplies T2 multiplies 1.5 atmospheres, and then the 2, that is 1 atmosphere, you multiply by 250 Kelvin. So you will have T2 times 1.5 is equals to 1 times 250 Kelvin. To get T2, we divide both sides by 1.5, where we are going to get 1 times 250 divided by 1.5. And what answer do we get?
One hundred and
100,
156.6.
156.67
166.
Kelvin, right?
160.
0.666.
Yeah.
So the answer becomes, let me write it in green, 156.67. Let me round it off, Kelvin. Right together.
Kami napata 166.
166.
Yeah.
Let me confirm the answer. 166, yeah. 0.66.
Yes.
The answer is 166. 166.67 Kelvin as our answer. Let us do example 2. Very fast. And example 2 says that at a temperature of 300 Kelvin, the pressure of the gas is in a deodorant can. In a deodorant can is 3 atmospheres. Calculate the pressure of the gas when it is heated at 900 Kelvin. So at this point we have to highlight. At this point we need to highlight whatever we have been given. We have been given temperature T1, P1, P2, T2. And T1 we have been given as 300 Kelvin.
Okay.
P1 we have been given as pressure 1, 3 atmospheres. We don't have pressure 2. And then we have temperature 2, which is 900 Kelvin. So with that, we want to solve for pressure 2. We apply the formula, that is P1 over T1 is equals to pressure 2 over T2. And then at this point, we insert whatever we have there. We have pressure 1 as 3 atmosphere. Pressure 1 as 3 atmosphere. Divide by temperature 1, which is 300 Kelvin, is equivalent to pressure 2 all over 900 Kelvin. If you want pressure 2, you cross multiply, where if you cross multiply, you multiply it with P2 with 300 Kelvin, 3 with 900, where we have 3
times 900 over 300.
times 900 all over 300 gives us P2.
3.
So pressure 2,
Yes.
the answer you get
9.
9.
9.
It is 9
Yes.
atmospheres. So that's how we do Gay-Lussac's law. So the definition of the state of Gay-Lussac's law is that simple. The pressure, it says that the pressure exerted by a gas, or it says that the pressure exerted by a fixed mass of a gas varies directly with the absolute temperature of that gas when the volume is kept constant. So just a minute.